Welcome to this video on detecting and understanding outliers in data mining. Outliers are an essential concept for anyone working with data. And in this video, we'll explore what they are, how to detect them, and how to deal with them effectively. Let's get started. Here's what we'll cover in this video. First, we'll introduce outliers and their significance in data analysis. Then, we'll discuss methods for identifying outliers, including graphical and statistical techniques. Next, we'll look at the impact outliers can have on models, followed by parametric detection methods such as Tukey's fences and Z-scores. Finally, we'll explore approaches to address outliers before summarizing everything we've learned. Outliers are data points that differ significantly from others in the dataset. These points can exist in one dimension or multiple dimensions, and they can cause issues with models that rely on averages or similar metrics. Identifying outliers is crucial for understanding their potential effects on the analysis. There are several methods for identifying outliers. Graphical methods like scatterplots, histograms, and box plots allow us to visually spot points that deviate from the rest of the data. Statistical methods, such as using interquartile range or Z-scores, provide quantitative ways to classify outliers. For instance, scatterplots can highlight points far from the main trend, making them easy to identify. Outliers can have a significant impact on models. They can distort summary statistics like the mean and standard deviation. And high leverage points can influence model parameters. Influential points, a subset of high leverage points, can drastically change the results of a model. It's important to note, though, that not all high leverage points are influential. There are two parametric techniques for detecting outliers: Tukey's fences and Z-scores. Tukey's fences use the interquartile range to classify points as outliers if they are far above or below the quartiles. Z-scores, on the other hand, identify points that are several standard deviations away from the mean. These techniques offer reliable ways to identify outliers in numerical datasets. The code snippet on this slide demonstrates how to calculate Z-scores and filter for potential outliers in Python. When addressing outliers, it's important to investigate their causes. Potential causes include data entry errors, measurement errors, sampling issues, or natural variability. Depending on the cause, actions can vary: correcting errors, excluding irrelevant outliers, or retaining them if they provide meaningful insights. For instance, if an outlier is a result of a natural phenomenon, it may be valuable to keep it in the analysis to ensure accurate modeling. To summarize, outliers are data points that differ significantly from others and can have a major impact on data analysis. Detecting them involves graphical and statistical methods like Tukey's fences and Z-scores. Once identified, understanding the cause of the outliers helps determine the best approach to address them. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.